5. I have a motorboat heading east, 16 meters a second, across a river that flows to the north at 9 meters a second. What will be the resultant velocity of the motorboat and its relative angle? So we know the motorboat will be going to the east, but will start to go to the north due to the stream. So you're solving for the resultant magnitude and its vector. First step, break down both components. If you recall, east is 0 degrees, while north is 90 degrees. So let's first break down east. East x, east y, 16 meters a second for both of them. X will have a cosine of 0. Y will have a sine of 0. Run this through the calculator. 0 cosine is 1 times 16 comes out to be 16 meters a second. Now let's run y. 0 sine equals 0 times 16. Return 0. Now let's deem this to be x1 and y1 so we don't get confused later on. Next step, let's do north. X, y. Magnitude was 9 meters a second for both. Cosine, sine. Cosine being 90, as well as sine. 90 cosine times 9 equals 0. Ninety sine times 9 equals 9 meters a second. We now have x2, y2. Now let's add them all up. x1, x2, sigma x. Same for y1, y2, and sigma y. x1 being 16, x2 0. This gives us a total of 16 ms. Now for y1 we had 0, and y2 we had 9. We have 9 ms. Next step, let's find the angle. Inverse tangent y divided by x. In this case 9 divided by 16. Nine divided by 16. Inverse tangent. 29.3. Let's round it up. 0.4 meters a second This is your angle. Next step, let's do the magnitude or the resultant velocity. Square root sigma x squared plus sigma y squared. In our case, 16 squared plus 9 squared. Run it separately. 16 squared, 256, 9 squared, 81. Add them together. 337. And then finally square root 18.3. Starting up to 18.4 meters a second. This is your magnitude. Now refer back to the question. Actually, a quick change right here. This 29.4 is your angle. Small mistake. Going back. Velocity 18.4 meters a second. Its angle being 29.4 degrees.